जीरो इंडिसेस वी आर समराइजिंग, ठीक है, समरी, सिर्फ वी आर समराइजिंग एवरीथिंग, ठीक है। जीरो रैंक टेंसर, यस, zero rank answer, no, zero, yes, you are right. Tensor, it will be invariant, okay, no indices, no free indices. Zero rank tensor means no free indices, and it means it will a scalar, it is a scalar, and it is zero, no free indices, no free indices, and it will always invariant under transformation, okay. One free indices transformation, one transformation law transforms as vector, okay. If there is a one indices, then that will be transformed as a vector. I have already. One rank, yes. You may say that one rank tensor, but it should be a true indices, and not as in the case of G alpha beta. There are two indices, but they are not two. They are a false indices. That is misguided. Yes. No, दो बहुत रोटेशन क्यों वेक्टर रोटेट नहीं करता, ट्रांसलेशनल एज वेल एज द रोटेशन बोथ यूज। हम बल्कि कंसिडर ज्यादातर रोटेशनल कोई करते हैं, जैसे यहाँ इस केस में किया, क्योंकि हमारा ज्यादा, क्योंकि ट्रांसलेशनल ट्रांसफॉर्मेशन कोई इफेक्ट नहीं करती, तो रोटेशन की सबसे ज्यादा इंपॉर्टेंट है, क्योंकि रोटेशन जो है वो चेंज करती है। वन ट्रांसफॉर्मेशन होगी, जैसे वो हमने किया था पार्शियल एक्स होगा, एक ट्रांसफॉर्मेशन होगी, ठीक है। एंड टू फ्री इंडिसेस, सॉरी फ्री इंडिसेस तो वो हो गया ना, रिपीटेड इंडिसेस, डमी, repeated twice, that will be a dummy index, okay. Repeated more than two false if sometimes and this is comes more than two times, repeat two times, I mean if alpha is coming two or three times in any term, three times, four times, five times, then it means your calculation is wrong. You have to, okay. फ्री इंडिसेस कंपोनेंट की ट्रांसफॉर्मेशन को, यस, वेक्टर्स को, यू आर राइट, फ्री इंडिसेस ही आपको हेल्प करता है। और क्या था? सी टी एक्स, ओके, नहीं नहीं, फिर गलती से लिखा गया होगा, कंटामिनेंट विल बी प्लस, कोवेलेंट विल बी माइनस. Because I have already explained. Actually, if you write it in the Euclidean space, okay, this in Euclidean space, x alpha is Ct iota x, okay, and if you take a complex conjugate, okay, in the signature of plus minus minus for plus minus 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 signature, ठीक है, but x alpha is Ct, oh sorry, actually क्या है, iota Ct, we have started from here, iota was along the Ct, that's the our starting point. Got it? So C was along the imaginary axis and X was along the R3. Okay? इसका नहीं, इसका नहीं, ये तो सेम रहेंगे ना, मैंने यही बताया था, मैंने आपको बताया, आप गलत सोच रहे हो, ये इसकी बात हुई थी जो आप प्लस माइनस की बात कर, आपकी बात, दिस इज what is the natural unit in natural, actually theoretical physics avoid the confusing, okay, all type of the confusion. So in, as we know that all physical quantities change with changing the unit because they are unit dependent quantities, and C is also a unit dependent quantity. We choose natural unit as the unit for which the magnitude of C is 1 or h cut value. Okay, what is the natural unit for this C and h cut? To avoid where I must mention the C or h. So to avoid all these things, I use the, okay, that is equal to minus. Yes. Actually, this combination. Why? Achha, you are asking why are you using the minus plus plus? Here it is minus and other is plus, and why I am using the minus? But here is no change. That is your question. Okay. For this length was minus c square t square plus x square plus y square plus z square. That's sorry. Yes. For this, that was okay. And when we change 1 minute, when we have changed the signature, this was signature minus plus plus plus, and this will be converted to this. Okay. But if we use c square t square minus x square minus y square after multiplying with the minus sign minus z square, this will with the due to this signature. So that's why the and this whole term is plus minus minus. Okay, so it affects only the covariant part. That's why, and all these may be right in the they. Oh. Okay, got it? Okay, so that's come from. When you compare this x naught is plus ct, Mishal, this x naught is plus, this up, this minus after. Okay, that's fine. Oh, sorry. Here, this was this. Okay. Okay. Yes. Minus c. Yes. If you change the signature, this will be divided. If we say yes, that will. हाँ जी यस कंसर्वेंट के साथ माइनस सी टी नहीं आएगा, कोवेरेंट के साथ जो है वो सी टी आएगा। मैं भी देख लूँगा, ठीक है? ओके, गॉट इट? ओके, अच्छा, नाउ दिस इज रिवर्स। या हेयर कंसर्वेंट 1 minute, हेयर कंसर्वेंट will be treated as covalent. And covalent will be because when it is a denominator, the conservative will be covalent, and if the covalent is in denominator, that will be a conservative. So that's why the partial derivative of conservative that will become here like this, and covalent like this. Okay. No. Complex conjugate, if that is right in the form of Euclidean space. If you write it as, if I write it in the Euclidean space, then this will be iota ct. So its complex conjugate will become, okay. Okay. Not transpose. Transpose, both will be a column matrix. Transpose will be converted. That's why we are using the semicolon. Dagger, if you using the, you are 1 minute. If you are using the Euclidean space, Euclidean means everything must write in the form of plus. Means this will be, this is in Euclidean space. In Euclidean space, you will take a complex conjugate. In Minkowski space, you will be take a conservative covalent form. You will not use this iota. But instead of iota, you will use the conservative covalent, because conservative and covalent itself, this is a mathematical technique. Both are the same. Technique is different. Okay. Whether you take in this form or whether you take in this form or whether you take in this form, it's up to you. Okay. Got it. If you take in contravalent covariant, then you will not use the iota, but you will use the covariant and contravalent as a complex number. This is like let me explain. As in the case of, we are actually next, our topic is about the complex number. Okay. Yes. नहीं, एक मिनट कर लो ना से. If this is a complex number, iota b, there is angle is 90. Okay. What we do? This is a real, this is imaginary, and the angle between them is 90. Sorry. Angle between them is 90. Okay. If in what is happened in the Lorentz transformation, this was x, this was y, x, y, z, o, and all x, y, z are a element of real x, y, z. You know that a dot b in R cube, a dot b is equal to b dot a. They are a real. Okay. Yes. In metric and FSC, you always study that a dot b equal to b dot a, because all elements of x, y, z are a real. Okay. In 3 dimension, this is a real. So these are the this is the element of R cube. But when you apply a Lorentz transformation, there will be a one imaginary axis, that is iota ct. That is real space, that will be along the orthogonal space, complex space. So this will be, if we consider joining with each other. So these are the two things. R3 real, इसे R3 कहते थे अगर linear algebra आपको याद हो, and this will be iota. This is, yes, and why this is a, अच्छा, this is R cube plus iota ct. Okay, so this is the combination of R cube ct. Why I am not writing I, or that there is a reason. I will, let me explain. Complex number is right in the form of a plus iota b. Okay, and it is always right in the form of a b, in the form of order pair. A will be a real and b will be, or you may write in the form of a and b. इसमें भी कुछ बुक उस फॉर्म में लिखते हैं या किस, ठीक है. आप मेरा ख्याल है ज्यादातर इससे फैमिलियर हो, मैं ये लिख देता हूँ. वैसे हम इसे कॉलम मैट्रिक्स के फॉर्म में लिखते हैं. जो एक्चुअली वेक्टर जितने भी लिखे जाते हैं वो कॉलम फॉर्म में लिखे जाते हैं. यही वजह है हम उसमें भी कॉलम फॉर्म में ए बी. ठीक है. और ये दिस इज रियल पार्ट, दिस इज इमेजिनरी, और यहां आयोटा नहीं आता. इसी तरह ये जो आपकी स्पेस है, मिनकॉश की स्पेस है, इसमें ये x है और ये जो है ct है, कॉम्प्लेक्स है. No, Minkowski and Euclidean are both the same thing. There is no difference. technique is different. What is in Euclidean word means the common, usual. Usually you write the component in the form of x square plus y square plus z square. If you write in the form of common sense x square, if you write the component in the form of no, dimension is same, everything is same, nothing is different. Only both are of same spaces. Actually नाम हमेशा कंफ्यूज करने के लिए यूक्लिडियन स्पेस इज नॉट स्पेस, मैं हमेशा ये कहूंगा यूक्लिडियन स्पेस मीन इफ यू आर यूजिंग दी मतलब सिंपल मैथमेटिक्स, मतलब यूजुअल मैथमेटिक्स जो पहले पुराने जमाने में चल रहा था कन्वेंशनली, यूक्लिडियन मीन वो वाला मैथमेटिक्स, स्पेस वही है, डिमेंशन वही है, सब कुछ वही है, डिफरेंट कोई नहीं है, रिजल्ट भी सेम है, पार्टिकल फिजिक्स में रिसर्च भी एक जैसी होगी, कोई रिजल्ट में फर्क नहीं पड़ेगा। फर्क क्या पड़ेगा? नोटेशन का भी कोई फर्क, हाँ नोटेशन का फर्क क्या पड़ेगा? फर्क सिर्फ इतना पड़ेगा कि आपकी कैलकुलेशन करने के मतलब सिंपल हो जाती है, जो आप मैथमेटिकली इंप्रूव करते हो, आप नई से नई मैथमेटिकल टेक्निक मिलते हो। इन मिनकॉस्की स्पेस में आपकी कैलकुलेशन सिंपल है, डायरेक्टली उस फॉर्म में कन्वर्ट। आपको यू हैव टू नॉट इन यूक्लिडियन स्पेस यू हैव टू कंसिडर आप एयोटा की कौन सी पावर ले रहे हो, प्लस ले रहे हो, क्यूब ले रहे हो, बार बार एयोटा को। इन यूक्लिडियन स्पेस आपने उसको, मैं दोबारा बता, मैं आपको समझाता हूं ना, मतलब बोथ आर द सेम, कैलकुलेशन इज सेम। मैं आपको सिंपल वर्ड में, दिस इज कॉम्प्लेक्स नंबर, इन यूक्लिडियन स्पेस यू विल राइट a प्लस एयोटा b, number is same, result is same, no difference, calculation will be same, but in, for example, you say that in Minkowski space you will use a comma b. Iota you will not use, but in your mind there will be this is a complex. You know that this is a complex. I mean, this is the real part, this is the imaginary part. This is the first, this is the second power. This is first element of power, order pair, and this is the second. Okay. If you are doing calculation in this way, that will be like a Minkowski space in four-dimensional space. If you are using the, if you are writing the length as x1 square plus x2 square plus x0 square, x1 square, x2 square plus x3 square. If you are writing everything is like this, and you are comparing the coefficient with the ct square minus ct square plus x square plus y square plus z square. In this case, you will consider that x0 is equal to iota ct. Yes, by comparing the coefficient. And x is x, y equal to y, z equal to z. Okay, there is no contravariant, no covariant. I mean, you will consider only this. Up complex conjugate ले, okay. But if you write in the form of Minkowski space, you will write in this. The thing will be same, length will be same, everything is same, but the method to write this in the form of tensor, one will be covariant, one will be contravariant, and you will write it x0 plus x1 plus x2 means, and you will say that minus ct plus ct x y z z. Okay, so in that case this will be equal to this, means minus ct x y z, ct x y z means contravariant. Means this will be a this will be a. If you write in the form of like complex number order pair form, then that will be a Euclidean होगा. Yes. Then you have to write in the contravariant in the covariant form. When you are writing in the contravariant covariant form, this will be defined as, this is a mathematical technique. Result, that actually result, this is a physical result. For both, result is different, but way of calculation is different. Like as actually here is C square, x naught is C, as I have already mentioned that x naught equal to minus Ct. Yes? Okay. And you are considering the four components Ct, x, y, z. But C component is may be confusing for someone. You have to take power of the C cube for C5 when you are multiplying it again and again. Then, but when you take in a natural unit, the C will be eliminated. That's when C is a 1, then 4 dimension will become a like this. If you are considering in a natural unit, 4 dimension will be minus t minus x minus, sorry, in 4 dimension, actually you are writing x, y, z in form of contravariant. In simple, actually you have start. In natural unit, because you are interested to avoid, C will be, in natural unit C is, in natural unit, magnitude of C, h cut, that is 1, then x alpha will be P, x, y, and z. I mean, you will avoid the C. I mean, that is, actually C is there, but C is there, but in natural unit, we have changed its magnitude equal to 1. Okay, so that's actually the way of calculation. There is nothing, result is the same, they will discuss the same particle, they will give the same result, but it may be, its calculation is difficult because you have to take the powers. One time you will consider iota square is equal to minus 1, then you will multiply. You have to consider again and again what is going on there. But in contravariant, that is changing itself. मतलब वो आपकी calculation, जैसे आप कह सकते हो ये कंप्यूटर पे करते, ठीक है ना, मतलब ये calculation, लेकिन उसमें सारे स्टेप हो रहे हैं, लेकिन वो calculation को सिंपल कर देता है. ये मैथमेटिकल टेक्निक इसलिए यूज करते हैं, अदरवाइज सेम कुछ भी नहीं. ठीक है, ठीक है. Yes, got it. So the most important, again, x alpha covariant, please note it, x alpha, it is partial over partial x alpha. Okay, we are summarizing everything. Okay. If in derivative, if it is coming, if it is superscript, then that will be a subscript. If, so that will be, we are considering in natural units. Okay, so what is this C? We are considering, yes, okay, and that will be, okay, and in the form of contravariant, this will be divided. Oh, sorry. In contravariant, if this is covariant, all will be positive. In contravariant, negative. Yes. Why? Because when this is come as a superscript in denominator, then it will be treated as a covariant, and the derivative will be all will be a positive. Because okay, when we are considering the contravariant, the denominator will become as a covariant and हाँ yes, ये मेरा ख्याल है यही होगा आपके. ओके तो सारा समराइज कर रहा हूँ, पिछली सारी चीजें रिपीट. ओके और मेरा ख्याल है आप जो बात कर रहे हो वो लेक्चर में यही होगा. ओके एंड वन लास्ट थिंग, if you are using the semicolon, it means this is the transpose of rho. Okay, got it. I have, whenever I use the semicolon, it means this is column. If I use the comma, not semicolon, then this is derivative and alpha. This is conservative. Okay, so yes, both are. Alpha as a superscript, beta is superscript. So when you write in the form of, they will be covariant that will be a negative plus minus and this will be plus. So this is beta if this is the case, okay, if there is a no semicolon, this is the case. Yes, this is derivative. But this will be a covariant derivative. Yes, conservative. Yes, yeah. Okay. So if gamma में है इस तरह का नहीं पढ़ा, अभी आगे पढ़ सकते हैं. ठीक है. If this is like this mean row and column. Okay. So I think all these topics has been we have discussed in the previous lectures. Okay. So this is the summarization of all the tensors. Okay. And you must be careful about all these and these. Okay. That will be used in your quantum field theories courses and okay. Got it?